Hi, everybody. It's Professor Mitchell. We're starting our last chapter today, and that is Chapter 9 on hypothesis testing for a single population. So the first section is Section 9.1, an introduction to hypothesis testing. So here you can see a little map of the different kinds of hypothesis testing we're going to talk about in this chapter. In the next two sections, we will talk about testing a claim about a population mean. And the procedure for that depends on whether sigma, the population standard deviation, is known or unknown. And finally, we'll talk about testing a claim about a population proportion. So a hypothesis is an assumption about a population parameter, such as a mean or a proportion. So an example of a hypothesis about a population mean could be something like the mean data used for smartphone users is sigma equals 1.8 gigabytes per month. An example of a hypothesis about a population proportion could be something like the proportion of cell phone users with 4G contracts is P equals 0.62. Every hypothesis test has both a null hypothesis and an alternative hypothesis. The null hypothesis, which is denoted by H sub 0, represents the status quo. It states a belief that the population parameter is either less than or equal to, or greater than or equal to a specific value. Notice that all three of these possibilities include equals. The null hypothesis is believed to be true unless there is overwhelming evidence to the contrary. So like they said, the status quo. The alternative hypothesis, H sub 1, represents the opposite of the null hypothesis, and I like to think of it as a challenge to the status quo. It is believed to be true if the null hypothesis is found to be false, and the alternative hypothesis always states that the population parameter is greater than, not equal to, or less than a specific value. So it never includes the possibility of equals. So this is a classic analogy for hypothesis testing. I didn't make this up. I wish I had. A criminal trial is a kind of real life hypothesis test. So in a criminal trial, the null hypothesis is that the defendant is innocent. Remember, innocent until proven guilty. So that's the status quo. The alternative hypothesis, which is the challenge to the status quo, is that the defendant is guilty. Now here we'll talk about some terminology that we'll get into a little bit later. Every hypothesis test has what's called a level of significance. This is the probability that an innocent person will be convicted. And in a criminal trial, this should be very low, right? Beyond a shadow of a doubt is what they say. The test statistic, which is the number that we will use to determine how much evidence there is against the null hypothesis, is the evidence presented by the prosecution. And then a criminal trial usually ends with one of two conclusions. Either the defendant is guilty, which in the vocabulary of hypothesis testing would be reject the null hypothesis. Remember, the null hypothesis was the defendant is innocent, or the defendant is not guilty. And in that case, we say fail to reject the null hypothesis. Now, the fact that we say not guilty instead of innocent is really, really significant. And that's because all of the burden is on the prosecution to prove that the defendant is guilty. So either they're going to do that or they're not going to do that, right? The defendant does not have to produce any evidence at all. So it is not on the defendant to prove that they're innocent. It is on the prosecution to prove that they're guilty, and either they'll succeed in doing that or they won't, okay? And so kind of along those lines, when we do a hypothesis test in general, the conclusion will either be reject the null hypothesis or fail to reject the null hypothesis. And we will put that conclusion into everyday English so that it talks about what that means for the specific problem that we're doing. The purpose of hypothesis statements is to draw a conclusion about an unknown population parameter. A hypothesis test is often performed to show that a change has occurred from the status quo. So in that case, you would reject the null hypothesis. The alternative hypothesis is used to represent the claim researchers wish to support. And because of this, the alternative hypothesis is also sometimes known as the research hypothesis. So again, the null hypothesis would be that the unknown parameter has not changed from the status quo. The alternative would be that there has been a change in some direction, all right? Stating the null and alternative hypothesis depends on the nature of the test and the motivation of the person conducting it. So this particular test would be used by someone who thinks that data use has gone up and wants to support that the average data use is now more than 1.8 gigabytes per month. Notice that the alternative hypothesis is mu is greater than 1.8. On the other hand, this test would be used by someone who wants to test an assumption that data use has gone down. Rejecting the null hypothesis would support the alternative that the average data use is less than 1.8 gigabytes per month. And then finally, this test would be used by someone who has no specific expectation, but wants to test the assumption that the average data use is 1.8 gigabytes per month, or maybe they think that the usage has changed, but they're not sure in which direction. A two-tail hypothesis is used whenever the alternative hypothesis is expressed as not equal to. So that would be the last example that we were just looking at. All right, so in this case, we assume that mu equals 1.8 unless the sample mean is much higher or much lower than 1.8. All right, so what you see here is a picture of a normal distribution with a mean of 1.8. And under this distribution, we will identify what's called a rejection region. And you can see that shaded here in orange. So we will collect a sample of a certain number of customers. We will find the mean for that sample. And if that sample mean falls in this region or in this region, then we will conclude that the mean is no longer 1.8. A one-tail hypothesis is used when the alternative hypothesis is stated as less than or greater than. This is an example of an upper tail test. We assume that mu equals 1.8 unless the sample mean is much higher than 1.8, specifically higher. In this case, the rejection region would all be up here, okay? So if the sample mean comes out to be high enough, and we will talk in the next few sections about what is high enough, then we will reject the null hypothesis. If it doesn't come out high enough, then we won't reject the null hypothesis. And then you have your lower tail test where we assume that mu equals 1.8 unless the sample mean is much lower than 1.8. And in that case, the rejection region would be down here. So much like you never find a defendant innocent, the null hypothesis can never be accepted. So you want to make sure you never ever say accept the null hypothesis. The only two options available are to either reject the null hypothesis or fail to reject the null hypothesis. The null hypothesis is tested using sample data. The sample result provides enough evidence to reject the null, or it does not provide enough evidence to reject the null. And of course, sample evidence is not perfect due to sampling error, so a conclusion about the population can be wrong. And that would result in what's called either a type 1 error or a type 2 error. So this is not the type of error that would cost you points on an exam. This would not be your fault. It's basically just a fluke in the sample. So a type 1 error occurs when the null hypothesis is rejected when it was actually true. And the probability of making that type of error is known as alpha, which is the level of significance that we were talking about earlier. A type 2 error occurs when we fail to reject the null hypothesis, even though the null hypothesis is not true. And the probability of making this type of error is known as beta. And we're not going to talk about beta too much, other than to say if you make alpha lower, generally that causes beta to go up. All right, again, think about the criminal trial. The more evidence that you demand the prosecution produce in order to get a guilty verdict, the more likely it is that somebody who, let's see, okay, I have to think about this for a second. Let's say that courts decided they're not going to convict anybody unless there's actual video of the person committing the crime. Well, then in that case, you're going to have a lot of guilty people go free, right? Okay, so this is a chart that you might find helpful. I think a lot of people have maybe trouble remembering which error is type 1 and which one is type 2. Type 1 is rejecting a true hypothesis. The probability of a type 1 error is alpha. Type 2 is not rejecting a false null hypothesis. And again, the probability of making that type of error is called beta. Of course, these other two outcomes would be correct. If you reject the null hypothesis and the null hypothesis is false, then you did the right thing. If you don't reject the null hypothesis and the null is true, then you also did the right thing. In terms of a criminal trial, a type 1 error would be the defendant is innocent but is found guilty. And a type 2 error would be the defendant is guilty but is found not guilty. And it's sort of a cornerstone of our criminal justice system that we are more willing to tolerate type 2 errors than type 1 errors. At least that's the way it's supposed to work. Benjamin Franklin said that it is better 100 guilty persons should escape than that one innocent person should suffer, is a maxim that has been long and generally approved. All right, so what Benjamin Franklin is saying there is that when you conduct a criminal trial, you should be a lot more worried about type 1 errors than type 2 errors. Okay. Here is a very simple example of type 1 and type 2 error. All right, I'm not going to comment on this. I'll just be quiet for a few seconds and let you look at it. Hopefully it's pretty self-explanatory. All right, so here's an example. Consider a manufacturing or quality control setting. The null hypothesis is that the process is satisfactory. The alternative is that the process is not satisfactory. A type 1 error is known as the producer's risk. When it occurs, the producer is looking for a problem in its process that does not exist. And a type 2 error is known as the consumer's risk. When it occurs, the customer is getting a product from a process that is not performing properly. When doing a hypothesis test, decide on a value for alpha before selecting the sample. All right, so again, the value of alpha reflects how serious would it be if you had a type 1 error. If a type 1 error would be just disastrous, then you want to set alpha pretty low, like 0.01, all right? If a type 2 error would be worse than a type 1 error, then you can set alpha a little higher, let's say 0.05 or even 0.1, all right? Once the value of alpha has been set, the value of beta can be calculated. We're not going to get into the details of how that works. And for, as I mentioned before, for a given sample size, reducing the value of alpha will result in an increase in the value of beta. And conversely, if you increase the value of alpha, that means the value of beta will be decreased. The only way both alpha and beta can be decreased simultaneously is to increase the sample size. Okay, I just wanted to double check there that that was the end of section 9.1, and it is. So we'll see you next time.